So I'm going to be talking today about issues related to body weight regulation and weight regain. I think one of the best ways to regulate our body weight around a healthy weight is for you to substitute public speaking for eating lunch. I don't get to eat while you do. So how did I get interested in this? Let me start by saying something that probably nobody in this room knows. When I graduated from high school, I've been involved in sports, all sports, never worried about my weight at all. And I decided I would just take the summer off. I had a job that required lots of hours, and I didn't exercise for almost 3 months. And then when I went to college, I was on the gymnastics team, and I had to lose a lot of weight. I gained a lot of weight over the summer. So my first year of college, actually within the first 3 months, I lost 25 pounds. I never thought that I would ever have a weight issue because I just didn't have to worry about what I ate. But that summer told me that I really did, but I knew nothing about how to lose weight. So I was trying to lose weight, and I looked into the grapefruit diet. I actually ordered a little pamphlet from a newspaper about the grapefruit diet, and I had really no idea. But I became fascinated with this idea that body weight is a phenomenon that is influenced by so many different factors, both internal and external. And I've been privileged to be involved in a number of weight loss studies over the years. And oftentimes what I see, some of the studies have been here at CSU, and I see individuals who have been in our studies, and they've gained the weight back. And I thought, we didn't do enough for them. And so I've been very interested in issues, not so much in weight loss, but more recently in how we can maximize the chances of long-term success, which I think is the goal. So with that, let me start with the objectives. I'm not going to read through all these. You can see these. But basically, I'm just going to go through some of the metabolic and biologic processes that influence our body weight, some of the complexities of energy balance, very little about factors that regulate food intake. We just don't have time. I underlined briefly because this is an incredibly large topic to address in a very short period of time. We only have 3 hours today. We'll look at energy expenditure, weight loss-induced changes in appetite and energy expenditure. And I want to introduce to you, and a lot of you know this already. I feel like I'm talking to, preaching to the choir here because I've had so many of you in class. But we'll talk about the energy gap, and then finish with some possible lifestyle approaches that I think could narrow the gap and enhance long-term weight loss. Now, my voice may be breaking up a little bit. It's not because I'm going through puberty again, but I've taught 2.5 hours already this morning, and so I'll be a little bit hoarse. So let's take a true-false quiz real quickly here. Now, I don't want to spend more than a minute or so on this, but the rapid increase in the prevalence of obesity indicates that for most humans, body weight is not biologically or genetically regulated. So just, in your mind, answer that true or false. Using the energy balance equation properly can allow us to accurately predict weight loss from either calorie reduction or increased physical activity. The major determinant of basal or resting metabolic rate is the amount of a person's total muscle mass. Okay? Or more than 90% of people who lose significant amounts of weight by dieting regain and lost weight in a year. 5, the inability to successfully maintain lost weight is more a behavioral than a metabolic issue. The loss of body fat after dieting usually results in decreased metabolic rate that's greater than predicted based on the loss of body mass. And then regular physical activity stimulates appetite and increased energy intake. Now, if you were to take this quiz and you get them all right, then you can take over. These are questions that might appear to have easy true-false responses, but in fact, a lot of these I think we'd have to answer with, well, it depends. Because there's so much complexity to this that is not going to be answered with just sort of a black and white true-false. And I put this quiz here because I want us to be thinking about these thoughts as we go through this. Now, a lot of this issue of weight regain has surfaced because of this study, and I think that Amanda also mentioned this, the biggest losers. And when we look at this is a fascinating study of 14 individuals that were studied. They lost weight over 30 weeks, and you all probably have at least seen some trailers or maybe even some episodes of Biggest Loser. With diet and exercise, massive amounts of weight loss. The average weight loss was 58 kilos. And then over a 6-year period of time, the average weight regain was 41 kilos. A pretty substantial amount of weight regain. Now, what is really disturbing about this is that when we look at the RMR changes, we expect resting metabolic rate to drop because of loss of respiring mass. When they lose that much cellularity, then we expect the metabolic rate is going to drop. But then they gained back 41 kilos out of the 58. And when we see this, but their metabolic rates after that 6-year period is actually a little bit lower, not significantly different, than when they lost all the weight. It was down, as we can see here, 610 calories, their RMR decreased. After the 6 years, and they've gained so much of the weight back, as we can see here, their metabolic rate's still down 704 calories from original. And this received a lot of publicity, and a lot of it, very negative, like, there's nothing we can do about this. We are metabolically destined when we lose weight to gain it back because of our metabolic changes. And I would assert that, in fact, a lot of the metabolic changes are going to be very difficult, but I think there's some things that we can do and we'll be talking about. All right, so energy balance. Simple concept, but it's got a lot of complexity. I don't know if you have seen some of the writings from Gary Taubes, but I find these fascinating. He actually has a degree in physics, as I understand it, but he's a science writer. And he says the assumption is that obesity is fundamentally caused merely by consuming more calories than our bodies choose to expend. But what if this assumption is wrong? What if the laws of physics have nothing to do with it? And there's sort of, in a lot of the popular press, this idea that, calories really don't matter. And that the energy balance equation, it's not valid. And Taubes will talk about hormonal aspects of obesity. And I think, well, wait a minute, the laws of thermodynamics still have to hold true. Otherwise, why even study this? Then everything is up for grabs. It's arbitrary. But the fact is, our laws of thermodynamics clearly do hold true. But it's the fact that this energy balance is so complex. There's so many layers of complexity that it makes it very difficult sometimes when we encounter individuals that seem to defy the laws of thermodynamics. They can't lose weight as readily as we would expect them to, or based on their diet or based on their exercise patterns. I think one of the reasons that we have issues with this, or that there's a lot that is sort of underneath the surface in the minds of many individuals who are practitioners and trying to help people lose weight, is that our energy balance equation really is very dynamic. And what we mean here is that when we change our energy intake, inevitably we're going to change our energy expenditure. And our energy expenditure, when it changes, can influence our energy intake. And the problem is we don't know how much of these changes are going to occur within an individual. What I'll show you some data that suggests that, well, here's the mean. Here's the average response in regard to this given perturbation. And we think, well, the average, that's what we're used to seeing as scientists. But the variability in response is incredible. And in my mind, this is one of the areas of research that you've got to push forward in trying to understand and not just look at, here's the aggregate data that shows, well, on average, this is what happens. Because there are so many people that are not average and respond very differently to a given metabolic perturbation. All right, so when we look at the biological control pathway, I'll put up this slide simply because I want us to recognize that even though we have a lot of environmental factors that influence what we eat and how much we eat, we still also have internal factors that can influence this. So when we look at our GI tract, we've got episodic appetite signals that emanate from the GI tract that are going to influence, various neurons in the brain, and influence then the expression of various neuropeptides that will influence our sense of hunger, our sense of satiety. And we've got those that will dampen food intake, appetite inhibiting, and these are cholecystokinin, PYY, GLP-1, and there are others as well. Then we've got ghrelin, which is orexigenic, that tends to go up when we are prior to eating, when we've been fasting for a while, and it tends to increase our food intake. And this has been studied a lot in animals, so less in humans, but still we recognize that these are important factors. But one of the things that we want to note over here, there's now a lot of interest in this idea that fat-free mass and resting metabolic rate may be signaling to our brain as well. And there's a group in Britain and several groups in the United States that are looking at this issue. And a lot of the focus has been on sort of the crosstalk between organs, with the skeletal muscle then communicating with our brain based on the fact that our skeletal muscle contributes significantly to resting metabolic rate. And I would suggest that that's a possibility, because we do know that there are myokines that are released, these molecules that can influence then the activity of other cells and other tissues and organs. But I would suggest that our fat-free mass is far more than just our skeletal muscle. I think there's more likelihood that we have the liver and other organs that are contributing then or sending signals to the brain, and that this fat-free mass and that's contributing to influencing our energy intake is not just skeletal muscle. But this is sort of a new area that is being focused on because there's a fairly strong correlation between our drive to eat and our fat-free mass. So when we look at our current environment, we have, as you all know, an obesogenic environment. And this is actually a hamburger that you can purchase in Pennsylvania. There's 6 pounds of ground beef to start with. Now, no single person is going to eat this whole thing, but the fact is we've got large serving sizes, as you well know. And it's widespread. Our food is relatively inexpensive. It's highly palatable. Much of it is high energy density. And again, this contributes to the obesogenic environment that we have. And then, of course, we have foods that we can purchase commercially here in Colorado. These are all foods that we can purchase here in northern Colorado, some at Centera, some here in Fort Collins. And you can see these are single servings. So we can easily get, close to 2,000 calories in a single meal. That doesn't mean that everybody is going to eat that many calories in a single meal when they go out. Some are going to take it home in a box, a portion of it, and eat it later. But nevertheless, this is going to make it a little difficult from an environmental standpoint when we're talking about sort of trying to counter some of the metabolic factors that would drive us toward weight regain. So when we look at the energy expenditure side, you've all seen this before. Basal metabolic rate, recognized, I view this as fairly synonymous with resting based on some research we did many years ago when we had people sleep here in the Gifford building in our lab, and we measured metabolic rate right when they woke up. And everything was well controlled. When we had to sleep at home and then we brought them here. And metabolic rates were no different, whether we did inpatient or outpatient. And so, at least in our hands, the resting metabolic rate and basal are pretty similar. And one of the ideas behind this is that it's our fat-free mass that contributes most to our resting metabolic rate. Then we've got the thermically effective food, we've got non-exercise activity, exercise, and this makes up our total daily energy expenditure now. The reason I put this slide in here is I want us to recognize one thing about our resting metabolic rate, which I've alluded to already, and that's that even though muscle mass certainly is a predictor, our fat-free mass is more than just skeletal muscle, and that's shown here on this. So when we look at the actual contribution of these various tissues and organs to resting metabolic rate or basal metabolic rate, we can see that muscle contributes, significantly, but it's very large in mass, percentage of our total body weight. And then we look at the liver. Almost the same amount as skeletal muscle, and yet the liver is very small in size relative to muscle. The liver is a very active organ. And I'm sure that in the very first talk that was given in this series by Mike Cagliassati, he made sure that you knew the liver was the center of all good things. I had to eat liver as a child once a week, and it was the center of all bad things. But of course the brain, the heart, the kidneys, these are all our internal organs that are going to contribute significantly. So if we look at our internal organs relative to skeletal muscle, it makes up a far greater component of our resting energy expenditure than this muscle. But still you'll see individuals that, well, if I start lifting weights, or you'll read these late period articles that will suggest that if we begin a resistance exercise training program, we're going to be able to increase our basal metabolic rate dramatically. Most people increase, their lean mass maybe by a kilo as a result of resistance exercise several times a week. That's not going to have much impact at all. And many people will not even have that much of an increase in their muscle mass because they spend more time talking in the gym than they do actually exercising. All right, so our current environment also looks like this. So if anybody recognize this? Anybody from Illinois?
Marshall Fields.
Well, this is Water Tower Place, where Marshall Fields is located here, off Michigan Avenue. I took this picture a number of years ago. So I sat at the bottom of the entry to the mall. I think it's got 6 or 7 stories, and I've just watched. So they got stairs over here, and they've got stairs on this side. And they've got escalators, and nobody takes the stairs. During the hour or so that I sat and just watched at the bottom, I could count the number of people that actually took the stairs on a single hand. It was just hardly anybody. And then on the escalator, they don't really use it as an escalator to improve or to increase their speed because they don't walk. They use it like a conveyor. That's really an elevator. They just stand. And so we have reduced requirement to engage in physical activity. And of course, this is contributing, and that's not new to any of you. All right, so let's begin to look at then, because I don't want to focus on what's causing obesity. I want to look at some of the changes that occur with weight loss. So when we look at the impact of weight loss on hunger and satiety and energy intake, I initially had a whole host of slides that we were going to look at. Well, here's MPY, and here's a goody-related protein, and we're going to get into some of the neurophysiology. I thought, well, this is probably not the best thing to do. Cliff is here. Where's Cliff? And Cliff's last class in neurophysiology was probably 10 years ago. So I thought, I better not do that. So we're not going to, I've taken out a lot of slides. But what I want to focus on is sort of just recapping what I would have said on those slides. So when we want to look at weight loss effects on adiposity-related signals and gut signals that are interpreted by our brain. So our adipose signals are insulin and leptin. Well, you all know that insulin is not secreted by our adipose cells, by our fat cells. But it's still considered an adiposity-related signal because it's secreted in proportion to the amount of body fat we have. And it's not an incredibly tight relationship because there can be decompensation that occurs, for example, with type 2 diabetes. But nevertheless, insulin tends to go up in circulation as we become fatter. So it is related to body fatness. Of course, leptin is related, and insulin and leptin are considered to be, as their action on the brain, anorexigenic, that is, they are going to decrease appetite, and also they're going to increase energy expenditure. Some of this mediated by increases in sympathetic nervous system activity. So when we look at the impact of weight loss, insulin goes down, leptin goes down, and there's a scientist at the University of Colorado, Paul McLean. He's spoken in our department before at the Smith Conference, and he has used an animal model mostly. But he's written a review paper. Some of you have read the paper, and it's really fascinating because he demonstrates all the benefits that occur with weight loss. And also how some of these very beneficial changes sabotage the ability to maintain the weight loss. And some of it is changes in leptin and changes in insulin that occur. So insulin and leptin are going to go down. Insulin goes down in the postprandial state as well. The hunger signals. So I would have showed you a slide that took individuals who were obese And it showed their ghrelin concentration was over a 24-hour period, and then after they lost weight. And ghrelin, remember, is a gut peptide. It circulates through the brain, and it stimulates food intake. So it's not anorexigenic, it's orexigenic. And ghrelin goes up then, and it's been well documented that this goes up with weight loss. And this could readily then contribute to an increase in the hunger that is characteristic of weight loss. And then PYY and cholecystokinin, remember these are anorexigenic, and they go down with pre-meal or fasting, and they're also, they don't respond as well in the postprandial state. And so again, there tends to be less satiety that accompanies ingestion of food in response to weight loss, at least based on these signals. And I would have shown you also not only the changes in these gut peptides, but also the changes that occur in individuals in terms of their subjective ratings of hunger and fullness and these kinds of variables. So weight loss also can produce changes in our energy expenditure. So we've got then individuals who, here's their components of their energy expenditure. This is a total energy expenditure. Then we got RMR, thermic effective feeding, exercise, non-exercise, and then they lose weight. And when they lose weight, the resting metabolic rate falls. And that's inevitable. I showed you that in the previous slide with the biggest losers. And it's interesting because when an individual goes on a diet and they're in an energy deficit immediately, but they still haven't lost much weight, they can still see a decrease in their resting energy expenditure. And some of that appears to be mediated rapidly by changes in circulating thyroid hormones, triiodothyronine, T3, also potentially a rapid decrease in insulin. And that's without much change in body weight. And then, of course, we expect that because they have less cellular mass now, that their metabolic rate is going to be lower. But in fact, most people, their metabolic rate will fall further than we would predict based on their loss of respiring mass. So that's an indication of greater energetic efficiency. Okay? The thermic effect of feeding, that's naturally going to go down because they're consuming fewer calories in order to lose weight. So, and I think all of you probably, or many of you recognize, there are differences in the thermic response to different macronutrients. So protein has the highest thermic effect. So our metabolic rates will go up higher with the higher protein intake, calorie for calorie, compared to fat intake and the carbohydrate. But the thermic effect of feeding, that's the calories that we need in order to process the nutrients that we've ingested. And then exercise thermogenesis, that can be variable. Some individuals could actually increase their exercise in response to a weight loss diet. Non-exercise thermogenesis also can be quite variable. I've indicated that these decrease because oftentimes they do in individuals who have lost weight. And if an individual is exercising and now they weigh less, then the amount of calories that they're expending to move their mass is going to be less. And so this can result in, again, an increase or a decrease in exercise thermogenesis. And then there's a group in New York that have been looking at energetic efficiency during submaximal, fairly low intensity exercise. And what they suggest is that when an individual is engaging in exercise on the order of about 25 watts, which is very low intensity, that they're actually more efficient, following weight loss. That in fact, they're expending fewer calories to accomplish that low amount of work. And that this contributes then, this increase in energetic efficiency contributes to a decrease in their total daily energy expenditure. And they would suggest that for many individuals, the decrease in their total daily energy expenditure is more a function of the changes or the increase in energetic efficiency with very low intensity movement compared to the change in resting metabolic rate. So it's quite interesting work, and this group has been doing work on this for the last 25 years or so. Really excellent work. So when we look at the corrective or the adaptive responses to weight loss following weight stabilization, And most of the studies that are really well done will do this. They will have individuals lose weight, and then rather than measuring a bunch of variables before and then right after they've lost weight, they'll want to stabilize them for a period of time at their new weight. And that's not always easy to do, but it's really important because there's a dynamic phase to weight loss that's different than the static phase of weight loss, where they've had that weight maintained for a period of sometimes it's a matter of as few as 3 weeks, or sometimes it's several months. And so I think it's best to actually take a look at these dependent variables after weight stabilization. But even then, we see a decrease in R bar, and much of that is because of the loss of body mass, but some of it also is because of an increase in energetic efficiency. There's a decrease in the thermic effect of feeding, less food, decrease in the energy cost of movement, again because of increases in energetic efficiency, and also the fact that they weigh less, greater hunger, less satiety, greater energy efficiency, which I've been getting at here. There's less energy required per unit of respiring mass. And this then leads us to the concept of the energy gap. And this is a fascinating concept here. Best explained, I think, by this paper by Paul down in Denver. It's the biological pressure to regain weight as a consequence of the increase in appetite and suppressed energy expenditure that accompanies weight loss. So the difference between appetite and expenditure requirements then is what has been termed the energy gap. So it looks like this if we want a diagram. So we've got an individual here who has reached a fairly steady state in regard to intake and expenditure, but it's at the cost of obesity. But their hunger and their energy expenditure are fairly well matched. So they're regulating at this higher body weight. This is before weight loss. Then they lose weight. Hunger goes up, energy expenditure goes down, and now they've got the gap that exists here. And in many ways, it's very unfortunate that this would occur because of this disconnect between these two sides, where it's almost unfair. Here my energy requirements go down, but I want more. And it makes it very difficult then for many individuals, and Paul would suggest, and others would suggest, that much of the difficulty that individuals have is not because they can't maintain, this new dietary pattern, because they lack adequate willpower or they can't change their habits adequately, but rather because there's this metabolic drive to regain the weight based on the increases in hunger, much of which can be explained by changes in gut peptides, adiposity-related signals, neuropeptides in the brain, and that our energy expenditure goes down because of changes that occur in energetic efficiency and loss of body mass. So it's potentially a very difficult situation, and many scientists would suggest that the very dismal rates of long-term success with weight loss can be explained largely by these metabolic changes. Well, you put these metabolic changes in the context of the environment in which we live, and it's almost like there's a double whammy. I mean, how can we expect people to be very successful? If these metabolic changes are occurring at the same time we live in the environment that we have. So I would suggest that maintaining weight loss, we need to focus on minimizing the energy gap. And we have to ask ourselves, is that even possible? I mean, the biggest losers somehow did not seem to be able to do that, despite all the exercise they were engaging in when they were losing weight. So it's a question that I don't have all the answers for, and I think there's probably a lot of brainstorming that needs to go on. And I'm going to again suggest that not everybody's going to respond in the same way. And we've got to start looking at things on an individual basis in real detail. So if we're going to take an individual who on the previous slide was obese and now has lost weight, and maybe they're still overweight, but they're experiencing the energy gap where hunger's gone up, energy expenditure's gone down. What we want to try to do then is to help them maintain this body mass by somehow attenuating the increase in hunger, and also attenuating the decrease in energy expenditure so that we can make it a little more feasible for these individuals then to maintain long-term weight loss. And again, I think it could be a tall order for many individuals. I didn't realize it would be a tall order because when I lost weight when I was in college, I had no trouble keeping it off. And I thought back on that time, and I thought, well, why did I have trouble? Or why didn't I have trouble when so many other people did? And that, I think much of it related to exercise. Well, here I'm going to talk about exercise in a department that focuses on nutrition. And Mary's here, and I appreciate your attendance here. You know, people sometimes ask me, which do you think is more important, diet or exercise? And I'm not going to answer that question given the audience that we have here. Well, I will have to say that both of them are important, but let me just mention one thing. There are some prominent scientists that have been recorded as, you know, in review papers or even in lectures, that have suggested, based on their comments, that exercise is really unimportant when it comes to weight loss. And I think there's a little bit of truth to this, given the fact that it takes a lot of exercise to create the same degree of calorie deficit that we can create by dieting. And it's not a fair comparison at all. And we got to look at what's occurring over the long term, and not just over the short term. But almost always head-to-head comparisons where they're not matching calories, but they're simply putting people in an exercise program versus diet. Diet does better. That doesn't mean that exercise is unimportant. I'm going to suggest that it's critically important. Okay, so let's look at some possible ways then that we could attenuate this energy gap. We don't have any clear-cut dietary recommendations for weight loss maintenance. But we don't even have good dietary recommendations for weight loss. We've got all kinds of diets. And we have all kinds of diets in some ways because none of them are more effective than others. I think if we had a diet that was really effective, the others would fall by the wayside. But there's lots of ways, you know, to lose weight. The National Weight Loss Control Registry, and I've just put the names of the two individuals, Reagan and Jim Hill, you know, the main investigators behind this to establish this weight loss registry, and it indicates all the publications, but there's a lot of them that have focused on this weight loss registry. To be in the registry, individuals have to have successfully lost 30 pounds for a minimum of a year. The average is actually 33 kilograms of loss over that's been maintained for 5 years. So a pretty significant amount. Now, what this would suggest right off the bat is that it's possible to lose weight and maintain weight loss. Now, I would also suggest that these individuals that are able to maintain the weight loss may be very different than individuals who are not, in terms of metabolic factors, genetic factors, epigenetic factors that have contributed to their body weight or their ability to maintain weight loss. They can be very different, and this hasn't been studied much. Rather, what's been studied is their behaviors primarily. But weight regain, and I've just took, you know, I've looked at a lot of the studies and sort of compiled some bulleted points that distinguish weight regain with the ability to maintain weight loss. So regain is associated with higher levels of depression. And again, even though people have entered the National Weight Loss Registry, there are some that have gained the weight back, but they've still been studied. Okay, so higher levels of depression, binge eating is more common, low levels of dietary restraint, higher energy density eating pattern, and low levels of physical activity, characteristic of these individuals who have gained weight back. And then the opposite, the successful weight loss maintenance, frequent weight monitoring. In fact, oftentimes weighing themselves every day. And sometimes I wonder, is that a good thing? That the focus is so much, you know, on monitoring weight and being very vigilant about that. But nevertheless, this is one of the factors that is associated with the weight loss maintenance. Very high levels of physical activity, reduced sedentary activity, so less TV, less screen time, lower energy density diets, and there's a variety of these, and actually the lower carb diets are now starting to be looked at in these individuals. They were not enrolled when the weight loss registry was initiated. high levels of dietary restraint, such that they have a great deal of vigilance on weekends and holidays, knowing that these are periods of time where a lot of individuals are prone to overconsume calories. So I think there's things that we can learn from this, but again, this is observational. This is not experimental, but it's still useful to recognize that some individuals are able to maintain some success with long-term weight loss. There's another registry which is in Greece, and this is a registry of both maintainers and regainers, is what they are called in literature in this registry. The weight loss maintainers versus gainers have greater physical activity, so we're going to see some common themes here. A dietary pattern emphasizing home-cooked meals. Oh, well, really? Instead of eating out all the time. Fruits, vegetables, unprocessed grains, nuts, lean proteins, low-fat dairy. Well, this is sort of like the Mediterranean diet, which we might expect in Greece. The lower intakes of salty snacks, sugary beverages, and alcohol. Eating more slowly. This showed up especially in women. And then greater protein intakes relative to body mass. So this is again based on, I think, 4 different studies that I looked at. Focusing, and this is the lead investigator in Greece, again, a number of different publications. Again, some information that's useful. And by the way, if you have questions as we're going through this, just fire away. All right, how about dietary composition? Could that play a role? Well, it's interesting to see. It's fun to have been in this career to span the time frame when Atkins first came out with his diet back in 1973. And then later, he came out with the second edition. And Atkins, of course, was vilified. You know, how could anybody suggest that reducing carbohydrates and increasing fat would have any benefit that would produce weight loss? And yet he had years of anecdotal information from his own clinic that suggested people did lose weight on that diet. And of course, he wrote about it. Dean Ornish would have the totally opposite approach, and they didn't particularly like each other publicly when they debated. But it was fascinating for totally opposing views on what's the best way to regulate not just body weight, but also health. And Ornish was focused less on body weight and more on risk factors for cardiovascular disease. But the Ornish diet, a lot of you, he actually spoke before Collins a number of years ago at the Lincoln Center, and he emphasizes a very low-fat approach, primarily a vegetarian diet. And we would want to ask ourselves, is one of these, any better than the other in terms of attenuating the gap? Okay, so let's look at that. So here's a study that was done, and I want to see, if you can call attention, if you can see something on here that probably isn't very real-worldish. But in this particular study by Rachel Banningham, what she did is she had individuals, the same individuals, both normal weight and obese individuals, eat meals that differed in their macronutrient composition significantly. So high protein, high carbohydrate, and high fat meals. So here they are fasting, and they eat the meal, 30 minutes after, then they rate their perceptions of hunger. And you can see with the higher protein in red that they were well satiated, and so their hunger was not as great over the next 3 hours. Relative to the blue, and that blue here is reflected by a high-fat approach, and here in black we have the high-carbohydrate approach. And the high-carbohydrate approach is, again, a significant amount of carbohydrate. So, and this is pretty similar also, and you'll be suggesting that hunger is not going to be as great in response to a meal that's high in protein. But I want us to notice something here. High protein, 65% of the calories come from protein. That's incredibly high. People don't eat that much protein, typically. Now, they could in an Atkins diet, in a meal, but even then, they're getting a fair amount of fat in an Atkins type diet, and fat is more energy dense, than the protein is. So on an Atkins diet, typically more of their calories are coming from fat than protein, even though they're eating a fair amount of meat. But nevertheless, this potential for protein to be more satisfying. All right, so then they looked at PYY. Remember, this is the anorexigenic gut peptide. And they they looked at the total both in the normal and the obese, and then also the most active form. And what they saw sort of mirrored what they were looking at previously with their subjective ratings. That in fact PYY was elevated to a greater extent in that postprandial period that was associated then with greater satiation during that period of time. So a physiological or metabolic explanation for the subjective ratings in these individuals. So a study that was done more than 10 years ago now in Europe took individuals who were overweight and obese, and they put them on a 4-week low-energy diet. And it was a pretty severely restricted diet. They lost between 5 and 10% of their body weight within just 4 weeks. Okay, so they slimmed down, and then they randomized them into receiving weight maintenance counseling. And then half of them were randomized to this group, weight maintenance counseling. They met the same number of times with a counselor, dietitian, to help them maintain that weight loss. But this group got an additional 48 grams of dietary protein a day. Okay, so they're not clamping, or they're not manipulating their diet between the two groups, their usual diet. They're giving them counsel about what they should be eating and what they should be doing to try to maintain. But this group is getting an additional 48 grams of dietary protein. And what happened? The additional protein group, during the 3 months of post-weight loss, when they were attempting to maintain, there was a 50% lower body weight regain. And that consisted only of a regain of fat-free mass. Also, there was increased satiety, decreased energy efficiency, as measured in this study. The actual protein intake as a percentage of calories, even though it increased by 48 grams, they calculated the percentage went from 15% protein in this group to only 18% of total calories in this group. I haven't gone back and verified their calculations, but this is what they're reporting. And 18% is a reasonable amount of protein. Institute of Medicine says we can have between 10 and 35%. Well, 35% is pretty high, but nevertheless, 18%, that's more reasonable. And so there's the potential then for higher protein intake to have an impact on one aspect of this energy gap, and that's the increase in hunger. And I can remember being in graduate school years ago, and the idea of increasing protein intake was, well, this is potentially detrimental, because we'll need some of the minerals, from our bodies. We're going to see potential stress on the liver and on the kidneys to have to dispose of the excess nitrogen then. But much of this, and I'm not a dietitian, so if somebody wants to take exception to things that I say, that's fine. But my understanding is that the Institute of Medicine is not going to suggest that we can have a fairly high amount of protein if in fact there is going to be damage that's occurring to a healthy individual. Still, I think 35% is unreasonable to maintain, but I think for an individual who has normal, healthy liver and kidneys, 20% is very common, especially among American men. We were doing a study a number of years ago, and some of the study was going to take place down in Denver, so we met with a research dietitian down there, and we wanted the individuals to be on 15% of their calories from protein. And the research dietitian down there said, well, we'll have to reduce their protein intake, because the average male is getting more like 20% of their calories from protein here in the U.S. All right, in a review paper by Heather Liney, she suggests this. Higher protein diets that contain 1.2 to 1.6 grams of protein per kilogram per day, that's higher than the RDA, and potentially include meal-specific protein quantities of at least 25 to 30 grams of protein per meal. Provide improvements in appetite, body weight management, and or cardiometabolic risk factors compared to lower protein diets. And then she goes on to say that although greater satiety, weight loss, fat mass loss, and the preservation of lean mass are often observed, the lack of dietary compliance can be an issue. Because a higher protein diet isn't necessarily very palatable. Although I think this is where we need to marry the industry of food preparation, with nutrition. And of course, we try to do that in the department here, where palatable foods also can be nutritious foods. All right, so on this same thing of macronutrient composition. So I also think that Amanda mentioned this study. So this was a study that was done by David Ludwig and his colleagues at Harvard. And they had individuals lose weight. So they had a regular run-in diet, and then they lost weight on a mixed diet. It wasn't any extreme diet, but a mixed diet, reduced calorie. And then they randomly allocated them by order into test dietary periods for 4 weeks each. So they had test diet A, test diet B, test diet C. But one of the test diets was very low carbohydrate. One of the test diets was low glycemic index. And one of the test diet periods was low dietary fat. And the composition, you can see here, carbohydrate relative to fat relative to protein. So very large differences. And the unique aspect of this is they're really focusing on weight maintenance. And now the weight maintenance is only a short time. But they wanted to look at some of the issues related to the energy expenditure side of this energy gap that is created by weight loss. So this is what they found then. So here's their baseline RMR values, expressed in absolute terms, calories per day. Here's their baseline prior to weight loss, RMR values, expressed calories per kilogram fat-free mass per day, so it's standardized. And you can see that their metabolic rate fell when they went on the diet. But here's the low-fat diet during that 4-week period of weight maintenance. Their metabolic rates fell on all of these. They were lower during that compared to baseline. When they looked at it relative to fat-free mass, what they found was that on the low-fat diet, weight maintenance diet, then their RMR was lowest compared to the low glycemic index diet and the very low carbohydrate diet. So what happened with what we would predict, that their metabolic rate fell to a greater extent than could be attributed to the loss of fat-free mass alone, so they became more energetically efficient. But that change in energy efficiency was attenuated most by the very low carbohydrate approach. And remember the low carbohydrate approach, only 10% of their calories coming from carbohydrates. So this is very much like an Atkins diet. And again, I'm not advocating this, I'm just showing some of the data that suggests this possibility that some of the change in resting energy expenditure, which makes up a significant portion of our 24-hour energy expenditure, some of that could be modified by dietary composition during that period of weight maintenance. Here's the decrease in total daily energy expenditure. Again, the very low carbohydrate diet came out the best relative to the low glycemic index diet and the low fat diet. Now, Dr. Ludwig has made a substantial amount of very good research with the glycemic index and glycemic load. If you read the paper, you'll find out that he still advocates the low glycemic index diet, because it was associated with the increase in cortisol levels that accompanied the very low carbohydrate diet, and also the C-reactive protein concentrations were lower. And he would suggest that putting all that information together, that the low glycemic index diet actually was better. That's up to the reader to judge. Again, this is an extreme diet. And this was manipulated for 4 weeks experimentally. That's very different than what people are going to be doing in a real world situation where they're in control of what they're eating. And so we have to take that into consideration. But I at least want to take a look at the diet. Now there's a caveat. And the caveat is related to something I mentioned already, and that's the variability in response. if you didn't see what's in blue, and these, what we see in blue, that's the summary box with the error bars, you see that the responses are all over the map. And so even though when we look at the aggregate data in blue, so here's our total energy expenditure, and it's highest with the very low carbohydrate. Here's the resting energy expenditure, highest with the very low carbohydrate. Look at the variability that's occurring here. Now, this adds another layer of complexity, because how do we know how an individual is going to respond? So one of the true-false questions I asked is, can we use appropriately the energy balance equation to accurately predict what the outcome is? My contention is we have a hard time doing that because we really don't know how people are going to respond. And I'll show you some additional data for that. About dietary fiber, I'll move through this a little more quickly. So there's the potential for dietary fiber to attenuate some of the hunger that accompanies the energy gap from weight loss. Some of that could be potentially related to CCK and PYY changes and reductions in ghrelin. This whole area of gut microbiota is fascinating. I'm not talking about that today because we have other people in the department who know far more about it than I do. Some people suggest that fiber is important because of this time energy displacement. That we have increased time to chew fiber, and we're not getting metabolizable carbohydrate from it. And that may be important as well. Now, how about exercise? So let me talk a little bit about this. So let's look at this exercise. So here's basically, we have an individual who's sedentary, and they want to lose weight. They've been told they need to start exercising, so they get some clearance, and their basal metabolic rate is 1.2 calories a minute. That corresponds to 1,728 calories per day from their basal metabolic rate. Their standing metabolic rate is going to be a little bit higher because as we stand, and I'm probably burning a few more calories than some of you because I'm standing, I'm balancing. I've got to contract muscles in order to not fall over. So metabolic rate is going to be a little bit higher. So they start an exercise bout. They listen to some of the recommendations they hear. I should be exercising 30 minutes a day, 5 days a week at least. So they initiate a program, 30 minutes per session, frequency 5 times, 150 minutes of exercise. And their intensity for the exercise, because they're sedentary, can't be terribly high. So it's 6 METs. So the metabolic rate has increased 6-fold. For those of you that are not familiar with METs, it's not a baseball team. And then 7.2 calories is 6 times higher than their basal metabolic rate. Okay? So the gross daily energy cost of the exercise, 30 minutes times 7.2, if my calculations are correct, 216 calories a day in exercise. But remember, they would have expended some calories anyway, even if they hadn't exercised during that 30-minute period. So I suggested that, well, let's multiply 30 times 1.4, that's their standing metabolic rate. Maybe they would have sat some of that 30 minutes, and they stood some of it. Maybe they walked a little bit, but let's give them a value of 1.4. So we multiply that times 30 to determine what they would have expended anyway had they not exercised. We subtract that from our 216. 174 calories times 5 days a week, that's 870 calories a week. That pales in comparison to this dessert that they can consume in 10 minutes. And so we have to be appreciative of the reality of what exercise can do in terms of energy expenditure. Now, if you are a long-distance runner like Dr. Braun, who's expending far more calories than 216 as the gross cost of the exercise bout, then obviously it contributes significantly. But for many individuals who are just beginning to exercise, they're not able to exercise at a duration and intensity that is going to contribute a substantial amount of calories or calorie expenditure relative to what we can get from our food. So what are the effects then of acute and chronic? Well, I don't have time to go into all that, but let's look at studies. Overweight, obese individuals underwent prescribed supervised exercise, 500 calories a day, 5 days a week, 12 weeks. We would predict, based on a static energy balance equation, that they might lose about 3.7 kilos. Look at the variability in response. Here's an individual right here that gained fat. Here are 4 individuals that gained body weight. Here's an individual that lost 30 plus pounds. Now they had the same exercise intervention. It was monitored, it was supervised. The variability in response is incredible. The investigators divided them up into compensators and non-compensators. Compensators, that is, somehow they didn't lose as much weight as was predicted, and these lost at least as much as was predicted. Most of them lost more. And what was the difference? The compensators had an increase of almost 250 calories in their dietary intake. This is based on self-report, which we know is notorious for inaccuracy. The non-compensators that lost more weight than predicted actually had a decrease in response to the exercise. And these were randomly allocated. These were individuals motivated to lose weight by exercise. And the variability in response was huge. So again, exercise has a place, but we'd like to be able to understand what is it about exercise that could influence this compensation that's occurring. These same scientists have suggested this. The effect of regular exercise on appetite regulation involves at least two processes. An increase in the overall drive to eat, but a concomitant increase in the satiating efficiency of a fixed meal. So that during that postprandial period, there's less desire to end that by finding food, by eating another meal. And these processes do not operate with the same strength in all individuals. Again, complexity due to individual variation. So I want to finish up talking about this concept of energy flux as it relates to attenuating the energy gap. So energy flux is a term that we use to describe the total throughput of energy in the body as a function of energy expenditure coupled to energy intake while they're in energy balance. Okay? So it refers to the absolute level of energy intake and expenditure under conditions of energy balance. Well, this is an adaptation from a study that was done years ago in Asia, looking at physical activity and calorie intake. And what was found in this particular study is that calorie intakes were lowest in those individuals that were moderately active, and this was primarily occupational activity. Those individuals that had high levels of occupational physical activity, manual laborers mostly, these individuals had high energy intake. Look here though, in the non-regulated zone, as this has been termed, individuals who were sedentary occupations, had energy intake that was much higher than these individuals who are moderately active. They did not regulate intake to match expenditure very well as sedentary individuals with sedentary occupations, suggesting the possibility that we regulate our energy intake to match our expenditure best when we're active. These individuals also weigh more, as we predict. So here's the concept of low energy flux. Low energy expenditure, low energy intake. Here's high flux. Energy expenditure goes up, we need to match it with an increase in energy intake. Could physical activity then change this? Yeah, for certain. Because of the higher energy expenditure that accompanies physical activity, resulting in the opportunity then to balance our calories with greater energy intake. But there's another way that we can do this as well. Suppose we have two adults, A and B. They lose significant weight. Both achieve weight stability over time. A does this by exercise. B does this. B is sedentary. So his energy intake over time is greater than his energy expenditure. He gains weight. Over time, energy intake and expenditure are the same in this individual, and they eventually are the same in person B. How did person B increase energy expenditure? By becoming obese. So we have two ways then to reach this state of energy flux. High energy expenditure with physical activity, or we can change our body size. And when we change our body size, our RMR goes up, energy cost of movement goes up, the reproductive food goes up, and eventually we achieve energy balance, but it's at the cost of being obese. So high flux, two different ways. Which one are we going to choose? Well, that led us to this study, and I'll finish with this. So again, the idea that once people lose weight, we would like to be able to see if we can decrease hunger and increase energy expenditure. So just focus on what's up here, not what's down here. I'm not going to present any of these data. But we had individuals that underwent some baseline testing, and we put them on a hypocaloric diet. So with Melissa's help with the Kendall Reagan Center, we had graduate students that helped individuals lose weight. They lost about 8 kilos, which was equivalent to 7% of their body weight over a period of time. We stabilized them for 3 weeks, and then we randomized them into low flux and high flux conditions with a washout in between. Now, 5 days is not very long, but we wanted to see if there were any differences in their metabolic characteristics in these 2 flux states over this 5-day period. And here's what we found. So energy intake, low flux, about 2,400 calories, high flux, about 3,200 calories. Because we were having them exercise. And we had them exercise a fair amount, but they were able to do it, even though they were not used to it. We then, and then here's our macronutrient intake. So we wanted to match macronutrient intake despite differences in calories. Here's our body weights over the 5 days. They stayed the same. So we think they're in approximate energy balance, difficult to measure over a short period of time. Here's their metabolic rates. Resting metabolic rate was on the average 80 calories a day higher in the high flux state, averaged over each of the mornings that we measured it on the high flux days compared to the low flux. It went up in every person except one. Here's then their fat oxidation was higher in all people except for one, while they were having the resting metabolic rate measured. Remember, one aspect of the energy gap is increases in hunger. So even though they're in energy balance, look at the differences in hunger on low flux versus high flux. Low flux, a lot less hunger, every single individual. In fact, we had individuals, almost all of them said, we can't eat all the calories you're giving us. And we said, you need to, otherwise you're going to be losing weight. And so they did not experience the same degree of hunger. Here's on average, how full did you feel in the evening prior to bedtime during these days? And again, every single person on the high flux state had a greater sense of fullness. So when we look at this then, I would suggest that exercise may be an excellent substitute for, in this case, snacking. We didn't talk about that. But it may narrow the energy gap by increasing energy expenditure, not just during the exercise time, but also with the throughput of calories during the resting metabolic rate time. And what tipped us off to this originally was we found the same thing in athletes on several different studies. And one or two even done with Chris Bell over in Health and Exercise Science when he was in Boulder. So this can allow then consumption of more food and experience less severe hunger. And again, regular exercise is the best, considered to be the best predictor of long-term weight loss maintenance. So I'll close with a quote here by J.P. Flatt. Regular chronic exercise allows fat oxidation, and I would say energy expenditure as well, to become commensurate with fat intake at a lower body fat content. So exercise thus appears to be a substitute for expansion of the adipose tissue mass. But one could easily conclude that expansion of the adipose tissue mass is a substitute for physical activity in bringing about weight maintenance, but it's at the cost of being obese. So, true-false quiz again. I'm not going to go through this, but again, I would want us to sort of consider, based on what I've said, what our responses would be. So, I'm out of time, but I'll take a couple of questions.
So why did not basal metabolic rate go up in that group of the biggest losers? Because they've gone up with, when you lose basal metabolic and you start re-eating, it goes up.
I don't understand, because it doesn't fit some of the prior research that's been done by Rudy Leibel and their group. Because they've had individuals gain weight as well, and their metabolic rates do go up. Overfeeding studies with Bob Bouchard, with James Levine have also shown increases in metabolic rate. In these studies, they didn't have them lose weight, substantial weight, and then see the weight regain. But I have no answer to that, John. It doesn't make any sense.
Do you think it might be the timing of the weight loss? I mean, they're losing a pound a day over.
Yeah. I've heard other scientists address this issue. Eric Ravison, who's a very accomplished scientist, has suggested that, maybe one reason for this is the fact that the weight was lost so rapidly. And if the weight hadn't been lost as rapidly, maybe there would have been less of this metabolic change that occurred that seemed to have some permanency to it. But I don't know that we have an answer to that until that's addressed experimentally. Other questions? Thank you.
Thanks again.
Okay.